G'day, lads and ladies, and welcome to the What's Up, Mate podcast, where everything is live, including the conversations.
Hey everybody. So today I'm just going to do a real quick rundown of Section 8, which is the testing and verification section in AS3000, which is the electrical testing standards. Now, some of you may or may not have seen a couple of Instagram reels lately just showing some substandard work, also highlighting current flowing through people's earthing systems, etc. Super important to understand testing and verification as a tradie in the electrical industry, as well as obviously refrigeration and air conditioning, because you're obviously connecting to an electrical supply that should have been checked by an electrician to say that it's up to its standard. So Section 8 is a pretty big section in the rule book. It uses a lot of big words, but it's actually very handy if you sit down and break it all down into the mandatory tests. We've got 6 mandatory tests that we should be doing on every installation that we install or certify. So these ones straight away, in order of sequence of test operation, is the continuity of the earthing system. So basically, we're just going to make sure that our earthing system is continual from the switchboard all the way through to all of our earthing points on our final subcircuits. We're also going to check our insulation resistance. That's in accordance with clause 8.3.6. So basically, we just want to make sure that the insulation of our cabling and any accessories that we've installed is suitable to liven up without short circuit. We're also going to check for polarity. So polarity is a really easy one to check, but it can often, especially if we're using XLP cables, etc., where we might have accidentally transposed an active with a neutral. That's where it really starts to get quite dangerous in an MEN system. So number 4 is our correct circuit connections. Now this is a pretty simple check in the switchboard, which we will do a video on how to do that one, but we're basically checking that our actives within our switchboard aren't connected to any other final subcircuits or submains, as well as neutrals to other neutrals. Earths are obviously going to be connected to other earths because it's one big system. We're also going to check that our actives aren't connected to our earthing or our neutrals of any other circuit as well. So pretty easy test to do, just with your voltmeter, your multimeter, whatever you choose to use. I would generally just use my multimeter on the ohm scale with the audible alarm on. That just allows you to quickly go through each sub-circuit and get it sorted. We're also going to verify the fault loop impedance. Now, there's a few methods on this one. There's obviously the way in which we're supposed to be doing it, which is testing everything dead, which is quite an easy thing to do. It's just very time consuming. So a lot of electricians will actually test this with let's say the Fluke installation meter live, which yes you can do, but in the instance of, let's say, you're reconnecting a home after it's been disconnected by the supply authority for growing drugs, or there's been a fire involved in that property, you're actually going to have to know how to test that while everything is dead. Again, super easy to do when you understand how to do it. My recommendations on that is a fly lead or a trailing lead is going to be your best friend. Now, whether that's just a roll of 2.5 building wire that you've got in the car, or you've actually got something more suitable with some banana plugs on the end of it for your multimeter, it's completely up to you. Obviously, a flying lead is going to look a little bit more professional for the client. At the end of the day, it's the same thing. It's just a roll of wire with some fancy connectors on the end of it. And then, last but not least, we've got the operation of RCDs. So obviously, we can't test the operation of an RCD if there is no power connected to the property. So our recommendations here in South Australia is returning to site to then test once the supply has been connected to the property. So yeah, pretty easy to do. Whether that's the bare minimum on that one is actually just pressing the test button on the RCD, which, yes, it proves that it works, but, can it be relied upon in the event of a fault? Injection testing is generally what we do. Cool. So for our fault loop impedance values, Section 8 actually gives us 2 tables. So table 8.1 and 8.2. Now, you might be wondering why. Why have they given us two tables for fault loop impedance? Well, table 8.1 is your fault loop impedance at 230 volts, so our live testing values. Whereas table 8.2 is your dead testing values. So basically what they've done here is they've given us two tables for two separate test values. Now you might be wondering, well, why have they done that? You know, we're still testing the same cable, we've still got the same circuit protection, etc., etc. Well, they've actually allowed for some form of heat within the cables when you're live testing. So there's a little bit more of a leeway in the live testing. So for example, a 16 amp protective device is a maximum allowable for a type C breaker, 1.9 ohms, so earth fault loop impedance. So ZS, so 1.9 ohms with a 16 amp breaker. So that is type C. But if we have a look at the type C circuit breaker for a dead test value, so 16mm breaker, 2.5mm cable, 2.5mm earth, we're going to be down to 1.2. So we've got a 0.7 ohm difference for that example. So again, table 8.1 strictly values for live testing, and table 8.2 strictly values for dead testing. Now, a lot of people say they don't need to test for their fault loop because, it's protected by an RCD. Technically, we don't need to test for fault loop if a circuit is protected by an RCD. As per the book, there is some exceptions in that. So that is, the exceptions are listed in AS3000, but we'll go into that in a bit more depth. But at the end of the day, RCDs fail, and so do circuit breakers, but RCDs fail more often than what we see failed circuit breakers. So you've got to be able to sleep at night and go, hey guys, look, we've tested your fault loop impedance. That's all good, because at the end of the day, if your RCD has failed, it may not guarantee automatic disconnection of supply with a touch voltage that can harm somebody, obviously. In that, you cannot guarantee that automatic disconnection of supply if the fault loop is over and above what's set out in table 8.1 or 8.2, depending how you test it. So that's just a really quick little tech talk, very basic. More than happy to run through it in a bit more detail if we get the feedback for that. Again, test is all we can say and do. At the end of the day, you don't know how many faulty installations are out there that we actually come across by doing these tests. So if you guys have got any questions about section 8 in the rulebook, just perhaps send us a message. Happy to reach out, have a chat. But basically, we really need to start to understand this section 8, and it is called mandatory testing for a reason. So thanks for listening, guys. I'll speak to you a bit later on. Catch ya.
Thanks for listening to an episode of What's Up, Mate? By an Aussie Tech for Aussie Techs.